All right. So this is question number 4 from the sine rule, cosine rule, and bearing homework. It says a ship leaves a harbor H and sails to port A, 45 kilometers away on a bearing of 64 degrees. The ship then changed course and sailed to another port B, 60 kilometers away on a bearing of 285 degrees. We're asked to I sketch the ship's journey clearly, showing one or A, the north direction, the bearings 064 and 285 degrees, and the points H, A, and B. All right, now, um, if I'm going to start, let's say I start with H. All right, so this is my point H. That's where I'm started. All right, at H, I'm giving direction from H, so I must draw my north, south, east, west line. Now, I then sail on a bearing of 64 degrees. That will put me somewhere in this direction. Bearing is measured clockwise from north, so the 64 degrees is this angle here. I sail from H to A. All right, so this is the point A. Then from A, the person change direction and sail 185 degrees. 185 degrees will put me somewhere in this direction. And he sailed, so here he sailed 45 kilometers. Here he sailed 60 kilometers. And this is to the point B. All right, the angle here is 285 degrees. The angle there is 285 degrees. So this is my sketch of the journey. 45 kilometers on a bearing of 64 degrees. Then you change the direction for 285 degrees to B, and B is 60 kilometers away from A. All right, question. So this is my north. So I was supposed to put in my north direction, which I did, the 64 and the 285 degrees, which I did, and the points H, A, and B, which I did. So I've completed I of the question. Now we're at II. II says the distance BH in kilometers to 2 decimal place. So I want this distance. The distance is BH. I'm going to call it X. All right. Now, it looks to me like HAB is a non-right angle triangle. If I can find this angle here, if I can find that angle there, I can determine the length of BH, which is X. Now, here's what I know about this angle. From here, coming all the way around is 285 degrees. This piece of it is 64 degrees. All right. So the first part is 180. This piece is 64. I'm going to call it theta. So I'll say to the examiner that theta is equal to 64 degrees. It's an alternate angle. There are alternate angles. Alternate angles are Z angles. So you can see clearly that this angle here is also 64 degrees. Now I want this middle piece in here, so which I'm going to call alpha. So next I'm going to say alpha is equal to 285, which is from north coming all the way around to the line connecting A and B. That's 285 degrees. So this is minus 180 plus 64. So the first half from here to here, that's 180 degrees from north to south. And from south to the line AH is 64 degrees. So the angle alpha is equal to 285 minus 244, 244. It looks to me that this is what, 41 degrees? Am I correct?
Yes, sir.
So that's 44 degrees. So now I have this angle here, which is 44 degrees. So now I have two sides of a non-right angle triangle and the inclusive angle. So if I have two sides of a non-right angle triangle and the inclusive angle, and I wish to find the length of the third side, it is a condition for applying the cosine rule. Now, the cosine rule says a squared is equal to b squared plus c squared minus 2bc cosine big A. Going back up to our triangle, A here is the inclusive angle. So this angle here, the 44 degrees, this is big A. Little a would be the side opposite the inclusive angle, and B and C are the other two sides. So let's put that information into the formula. A is X, B and C are 45 squared plus 60 squared minus 2 times 45 times 60, the cosine of the inclusive angle, which is 41 degree, not 44, 41 degree. All right. So let's work, all we have to do is work this out. All right, 45 squared is 2025. 60 square is, I think, 3,600 minus 90 times 60 is what? 5,400. Let's find out. Yeah, so this is minus 5,400, the cosine of 41 degrees. This is 5,625 minus 5,400 cosine 41 degrees. Now, the opposite of square is square root. So x would be the square root of all of this. And I would just simply put that in my calculator and press equal. So it's the square root, open bracket. The brackets are important. 5,625 minus 540 cosine, 5,400 cosine 41 degrees, close bracket, press equal, and the and x, which is HB or BH, or did they ask us for it? So HB, and the one the answer correct to 2 decimal place. So HB is 39. So this is HB, and it is 39.36 kilometers. So the distance HB is 39.6 kilometers. Let's go back up now to the last part of the question. The last thing we're asked to find is to determine the bearing of H from B. We're to determine the bearing of H from B. So if we're determining the bearing of H from B, At B, I need to draw my north-south line. It is the bearing of H from B. All right, I need this angle here. That's the angle I need. It would start from north and come around to the line that connects H and B. That is the angle I need. So what I need is this piece especially. Let's call it beta. I need that piece. I'm going to call it beta. So for that piece, I can use sine rule to find it. And the next piece I need the top piece up here. So let's write the B out there. So all right, I need this piece of angle. It's called alpha. Um, I use theta already. I can't talk to you now. I'm doing something. I don't know where you're going to get that. I can't do that now because I'm teaching a class. Another time. All right, sorry about that. All right, so I need to find this piece. I'm going to call it gamma. And I need to find the bottom piece. If I can find those two pieces, I'll have the answer that I need. I know I can find it. First of all, from here going all around, way around to here is 285 degrees. So I can find this angle easily. Let us call it, I'm running out of Greek letters. That's omega. Let's call it omega. So what I will say is, I will say that omega, is equal to 360 minus 285 degrees. minus 285, and this is equal to 75 degrees, and this is angles at a point. All right, so this is 75 degrees. If this is 75, this angle here and gamma up here, so they are co-interior angles. So I can say that gamma is equal to 180 minus 75. It's 105 degrees. They are co-interior angles. So I have this piece, which is 105. To get the bearing of H from B, I need this piece here. Now, to find that piece, I'm going to have to use sine rule. You see, after you use cosine rule on a triangle, the next rule you must use is sine rule. So I want to find the angle, so I'm going to say the sine of the angle beta, which I want to find, over the side opposite to that, which is 45 kilometers, is equal to sine of some other angle that I know. I know this angle is 41 degrees. It wasn't 44, it was 41. This angle was 41 degrees, not 44. Sine 41 degrees over the side that is opposite to 41, which we got 38, 38.36. So 39.36. I'm going to use my half cross multiply to say that sine beta is equal to 45 sine 41 degrees over 39.36. 0.36. So 45 sine 41 divide by 39.36. And I'm going to write the answer to 3 decimal places. So sine beta is equal to 0.750. Beta is equal to sine inverse 0.75. Beta, so it's shift sine 0.75, and this is 49 degrees. This is 49 degrees. And so I know the two angles now. One is 105, the other is 49. So now I can say, to end the question, the bearing of H from B is equal to 105 plus 49. The answer is 154 degrees. The bearing of H from B is 154 degrees. The question was a bit lengthy. It had quite a bit of curves and turns, but it did not include any knowledge that you don't already have. It did not include any knowledge that you don't already have. I recommend that you do the question over, look at the video, do the question over to ensure that you fully understand. Additionally, try and practice as many other questions as possible to ensure that you cement this idea of circuit theorem and sine rule, cosine rule, and bearing.